Alright, in 5.6 we are going to revisit synthetic division, and we're going to see how it's used in answering more complex problems. If you do not know how to do synthetic division, then you need to look back at some of your, I don't know what section that was, I'm sorry, but you could always email me and I could tell you, but I'm not going to reteach synthetic division if you did not do your job last semester. We will also look at another process that utilizes the complex conjugate in a different way. So we learn how to do the complex conjugate to rationalize denominators. Today we're going to look at something else. So synthetic division and the remainder theorem. Let's use our calculator to evaluate this problem real fast. So what we do, if you remember, is you take 3 times, again using parentheses, 2 to the third minus 2 times 2 squared minus 5 times 2 plus 1. By the way, those of you who are doing long problems with paper and doing all that stuff, you can stop doing that at this point. I appreciate the hard work that you've done, but I am not here to make you reinvent the wheel. Use your calculator because these numbers are going to start getting ugly, which means just type it into your calculator. I'd say get a calculator like this, TI-30XS Multiview. Again, the multi-view is important. This actually does fraction work, root work, as you've seen. It does a lot, and I think it's only like 13 bucks. You can find it at Walmart. No, Walmart might have it, but typically I think Walmart does have it. Just not like Walgreens. It has to be a bigger store that has electronics because they usually don't purchase these. But again, it's about 13 bucks. Shovel a couple people's driveways, get 10 bucks for it, go get you a calculator. There you go. That's the hustle. So that is the first part that we would again do, is just plug that in using parentheses and get your 7. But let's see what happens if we divided using synthetic division this by that. What we learn in synthetic division is we take the number that would make this 0, which just means take the opposite of that number, which is 2. Notice how that matches this. And then we put the coefficients of this and list them. That the next thing we do is bring down the first value and multiply. Again, I'm not going to reteach this. Add, multiply, add, multiply, add. We learned that this was our remainder. But what do you notice about your remainder when you look at the problem that we just did? And it is that the remainder of dividing using that number corresponds with the value of using it to evaluate. So what this pretty much does for us, even though it doesn't make sense in terms of realistic application, is you could actually evaluate this using synthetic division, but again, I don't know how many of you would actually choose to do it. It's just a tool that you could have if you had to. But again, the general idea is that it connects it helps us with another topic that's going to be important for us this chapter, which is factors. Something is a factor, I believe it's on the back part. Something is a factor of another number if it divides evenly. 4 is a factor of 20 because 20 divided by 4 is 5, remainder 0. X plus 5 is a factor of this because it divides in clean. But those are easier values to identify. What if I asked you to determine whether x minus 5 is a factor of this long piece here? Well, based off of what we had before today, we couldn't do it, but now we can. What we can do is say, well, if this is a factor, then when I divide it, my remainder should be 0 using the remainder theorem. So I will take a 5, because remember you use the opposite, and then I'll put the coefficients. And then I'll go through the synthetic division process, which should be decently quick by now if you've, again, worked on it like you were supposed to. 1, multiply, add, multiply, no, 50, I'm sorry. So add, multiply, add, which is 6, multiply, which is 30, add, which is 66, multiply, which is 300, because 3 times 6 is 300, plus 30 was 5 times 6 is 30, so it should be 330. And 288 minus 330 obviously is not going to be a factor, but again, on your homework you are going to have to show all these numbers because I do love it when you have to show the work. And that is 42. So the answer is no. How would I know if it was a factor? Well, if it was a factor, I would get a 0. Alright? So what this tool did for us is it allows us now to take a factor and check to see if it works inside of here. What does that do for us? It helps us with our factoring. So far we have not been trained to factor anything like this. What we learned to do if there are 4 terms is split it and then factor each to the front and back. But if you look at this, this has a factor of 1 and 2, right? Because 2 divided by 1 is 1. This has a factor of 1 and 3, which means that grouping, which we learned, will not work here and we would be stuck. But what if I told you in a problem, and by the way, this is a homework problem you're looking at here, so you might want to copy it. What if I told you with this that x plus 2 is a factor? If I gave you a clue and told you x plus 2 is a factor, well, what I would do is I would take this x plus 2, put a negative 2 in the box, right? Then put these coefficients out here and do my synthetic division. Add, multiply, add, multiply, add. What did I just get? What did I do to myself? 1, 2, negative 4, 12, negative 2, 0, 0. Ah, no. I messed up somewhere. Of course I messed up somewhere. Give me one moment, please. For the sake of being safe and knowing that it works, I'll check it on the computer right now after I do this. I'm just going to turn this into an 8 and save us all a lot of problems. So make that an 8. But anyway, in that problem, if I told you x plus 2 is a factor, you would multiply here, I'm sorry, minus 8. Because I'm smart like that. And then 8 here and 0 there. So our synthetic division, which was kind of fudged here, does give me a 0. X plus 2 is a factor, but remember that we could turn it back into as it says here. I think I'm getting ahead of myself. So synthetic division gave me a 0, but now let's complete this synthetic division and convert it back to expression form. What we should notice is something good. Remember, that's your remainder. That is a constant. 1, 2 x's, so that would be x squared minus 4 is what we end up with. Can we factor x squared minus 4? The answer to that is yes. That's x plus 2, x minus 2. So again, I know I messed up the original, but here's the point. In the problems that you'll see on your computer, they will give you a factor. You will use that number in synthetic division to divide. You should get a 0. If you don't, again, email me and let me know. But what you have left over can now be factored using the skills that we learned, I believe, in chapter, I don't know where, I think it was 5, maybe, I don't know, 3, somewhere around there. But anyway, that part makes it so that we can actually, once we know one of the factors out of the 3, we can go there. So today's lesson is going to pretty much ask you to find the remaining factors from a starting point. It will also do the same for finding remaining solutions. Remember, solutions and factors are related. The solution of that would be x plus 2 equals 0, which means it would be negative 2. That would be x minus 2 equals 0, which is 2. Anyway, you'll learn that, or you actually learned that already. But be sure to work for understanding on this part. Again, I know some of you like to use that shortcut that you shouldn't be using, because eventually you're going to be asked to find all the factors for every solution, giving nothing but an observation tool. I'm going to show you in 5.8, I believe. So this is another question you're going to see. I hope I wrote this right this time. Given a polynomial and one of its solutions, find the remaining solutions. So this is the polynomial. This is a solution. Remember, solution goes in as is. So 2 is a solution of this. This is not a factor. Your factor would have been x minus 2, but again, that is a solution. So we're going to put it in the box. Again, I'm kind of crossing my fingers here, hoping I didn't mess this up. I'm pretty sure I didn't, but life happens. Going through this, bring down, multiply, add, multiply, add, multiply. Yes, I did it right. It always feels good to do it right after you've kind of messed up like I just did. So anyway, 2 is a solution, and the reason we know 2 is a solution is because we should get a 0. But what you want to do now is take this part that is constant. Pretty much it goes, if x to the third to start, it should always start with x squared because you just took an x out. So it'll be x squared minus 8x plus 15, which going back again means I'm looking for numbers that multiply to be 15 and add to be negative 8. Those numbers are 3 and 5. If you want to make negative 8, it should be negative 3, negative 5, which means that it should be x. Because that's a regular x there, one of the shortcuts I taught you was as long as it's a regular x squared, we don't need to do the grouping. Just take those parts and bring them into the parentheses. that would be my other two I'm sorry, that's not my two solutions. Those are my two factors. My two solutions should be 3 because x minus 3 equals 0 will lead me to 3 and 5. So these actually are the last parts. If I was looking for factors like I did before, I can't find that paper. I think it's over here in the garbage. When they gave me a factor, which was here, I ended off with factors. All right. When they gave me a number, then I should end off with numbers. That was what I did wrong. But again, the factor part is important because we have to factor to get the solution, but that's pretty much all that there is to that. All right. So again, copy that problem, replay it a couple times to make sure you understand the game plan again. And again, that way you can actually start it. Again, the best way to take your notes is to make sure you put little explainers in there. So even though you might see this part here, you might want to write down use opposite of x plus 2. That's why I use a negative 2. So whatever you have there, you should have something in there kind of explaining what's going on. Just don't explain why I messed that up when I did it. But anyway, you are going to be asked to work out both types of problems in your homework. And again, what I just gave you should provide a solid starting point. Let me know where your issues are. I really do love helping you as long as you're doing what you're supposed to do. What I don't like is when you work me to death after not doing what you're supposed to do, because you're cheating me then. You're using my kindness, and then the first thing you'll do if I don't help you is say that I didn't do my job, when the essential truth is you never did yours, and you're mad that I'm not just giving you all the answers. So anyway, our next topic involves imaginary numbers. When it comes to factors and roots, every imaginary value is automatically paired up with a conjugate. So again, when it comes to roots and factors, if you have an imaginary factor or an imaginary root, you know it's going to be paired with something. So 5i, if 5i is a factor, then negative 5i is also a factor. That would be its conjugate. That would be 0 plus 5i, 0 minus 5i, but again, that has to be a fact. If we know that 2 minus 3i is a factor, then we also know that 2 plus 3i is a factor, or not a factor, but a root. Then because that's, again, how the game works, you just have to kind of add that to your understanding. In one of our past lessons, we were asked to do a problem like this. Write a polynomial with roots of 5 and negative 3. And what we learned to do is say if the root was 5, then we would put the opposite of 5 in parentheses. If the root was negative 3, then we put the opposite of negative 3 in parentheses. We multiply it out, x squared. What you learn to do whenever you have, and I'll talk about this now because it comes in handy, and you should have already learned it, as long as both of these are regular x's, your middle term is simply going to be this plus that. Negative 5 plus 3 is negative 2x. And then your last term is going to be this times that, which is negative 15. And so that would be it. So if I was to do x plus 6 times x plus 2, for example, it would be x squared. 6 plus 2 is 8x. 6 times 2, 12. If I were to ask you to do x minus 4 times x minus 11, it would be x squared. Negative 4 and negative 11 make negative 15x. Negative 4 times negative 11 makes plus 44. So again, as long as it's a regular x, there is not a shortcut, but you end up with this being negative 11x, that being negative 4x anyway. But again, using common sense, you can kind of get that middle term faster. But anyway, we learned how to do that by taking this, switching it, taking this, and switching it, and multiplying it out. Now what we're going to be asked to do is the same process with imaginary values. So before we get to that, let's make sure we improve our skills simplifying first. This is a homework problem that you're going to see, and it actually is going to walk you through it. X minus 6 plus 2i, x minus 6 minus 2i. So here's the conjugate, 6 plus 2i, 6 minus 2i. I am putting x minus those things in parentheses, which we'll see why in just a second. First thing it tells you to do is distribute the sign, which means x minus 6 minus 2i, because this switches to 2i. And over here, x minus 6 plus 2i. So again, this turns out to be negative, that turns out to be positive. Group the like portions. Notice both of these have a x plus 6, or x minus 6 on it. So what we're going to do is turn this into parentheses, parentheses, x minus 6 minus 2i. And we're going to turn this into parentheses, parentheses, x minus 6 plus 2i. What does that do for us? It gives us the difference of squares. This times that with a plus and minus. And what does that do for us? It means that the middle term is going to go away. If you remember from our conjugate work, that this times this is going to come out, this times this is going to come out, and everything else is pretty much going to go away. So what happens is you're going to take front times front, which I just showed you how to do, which is x squared minus 12x plus 36. Again, where did I get that from? X times x, yes. Negative 6 plus negative 6, negative 6 times negative 6. And then when you multiply the back part, which is what we learned in our last lesson, that the middle term goes away, that we get negative 4i squared. Now we simplify the square, which means this, remember I squared is negative 1, which means it's x squared minus 12x plus 36 plus 4, because again it's negative 1. And then when you simplify that out, you get x squared minus 12x plus 40, because those two things go together. Sorry, you could not see that. Why am I making you do that? Because again, I need you to learn the process, and once you practice that enough times, you will get it. Again, if you just kind of get over the idea of complaining about it, everything else kind of works out. And again, you just have to leave yourselves time. Most of the people who gave me issues in terms of like blaming me for their problems were the people who waited until like Saturday to start working, even though I assigned it on Monday or gave it out on Monday. And that makes no sense. If you start on the day that I put these things out, which is typically on Monday, and you do a little bit over the course of the week, you can actually spend 20 minutes working on this on a Tuesday versus trying to rush through it and getting mad at me because I'm not just giving you the answers on Monday when you have like one more hour to take your test. So what we're going to see here is a question that says write a polynomial with a root of 9 minus 8i. So what we can do here is put x minus parentheses 9 minus 8i, because if you remember the problem that we did earlier, let me find it. It's all over the place. Did I lose it already? No, it's on the back side of this. Or is it? It's not on the back side of this. Where did I put that thing? Ah, there it is. That when we wrote roots of 5 and negative 3, we put x minus 5 and we put x plus 3 because we switched it. So, same thing here. If 9 minus 8i is a root, I want to do x minus 9 minus 8i. But remember the rule I told you, this is a complex conjugate. So therefore, a root, therefore it's going to be an opposite, which means the conjugate's going to be there. So if 9 minus 8i is a root, 9 plus 8i is also a root, so x minus 9 plus 8i should be our start. Why do we just do what we just did? Because we have to do it again. We will now distribute the negatives, so x minus 9 plus 8i, x minus 9 minus 8i. Group up the parts that are the same, so x minus 9 plus 8i, x minus 9 minus 8i. This is a difference of squares because you have the same thing being multiplied in both with a plus and a minus, so the middle terms go away. The shortcut we learned is take front times front. Again, the way I showed it to you, x times x is x squared. Add these two numbers, which is minus 18x. Multiply these two numbers, which makes plus 81. And then multiply the back parts, which is minus 64i squared. 64i squared is the same thing as plus 64, because remember that's a negative 1, so it simply switches it. And our last step is x squared minus 18x plus 145, I believe. So that represents your 20-minute presentation. And trust me, if I could make it shorter, I would. But I think I have to explain these things and again kind of give you some hints in terms of some of the shortcuts that are there. But like I said, this video will be available for you pretty much all quarter at least. And if you ever need it again, just email me and let me know. Remember that you have to have both of these assignments up to 70% to take the assessment. Please be sure not to put off doing your homework until later. It could result in a 0% grade being put in for your initial assignment there. So work hard. And also, I think I put it on one of my future worksheets because I wrote those out already. Remember that 90% on homework opens up the pretest for you. So if you can get up to a 70, you might as well work your way up to a 90 also, but you have to do that by a test day. So other than that, like I said, work it out. Let me know where you have issues. Email me what I need, which is the work that you've done, and I'll be glad to help you out. Good luck.